Hey everyone, Florida Man here. This is part 2 of our 3-part series of building drones. Part 1 was me purchasing the parts and going over what parts I purchased. Part 2 is going to be me assembling the drone. Now primarily this video is just going to be me doing the physical assembly. I'm not going to go too much into the software side of things. If I did so, then the video would take too long. That's going to be in part 3. But if you want to do a follow along of assembling a drone, go ahead. This is the video for you. Also, this is my first time creating a video like this. There was a lot of voiceovers, there's a lot of video editing. It took me a lot longer. It was a big learning curve for me. So hopefully you guys find this video informative, a little entertaining, but primarily you learn how to build a drone from this. So you can also use this as a follow along. And if you want to support me in my efforts, my PayPal is down below, and so it's a link to my nonprofit. All right. Thank you guys. Enjoy the video. The first step in assembling our drone is going to be unpacking the frame and taking out all the parts here for the frame bit. So you see right here, we have the frame, we have the screws for the frame. We have some extra bits here as well. So the first little packet here, you see these little shock absorbers, and there's also a little bit there for the camera holder. We're not going to need any of these parts for the type of drone that we're making. Now the shock absorbers, obviously these are like civilian types. You'd put these at the bottom of the frame to help keep the supported if, for takeoff and landings. The other bits there, that's for a camera, but because our cameras is going to be a 3D printed stand, we're not going to be using those parts. And you see the next part here are the columns. This is to hold the drone up. Next, I'm just going to go through all the little screw packets. It's very important. Things get very messy very fast when you start building your drone. The name of the game is to keep everything as compartmentalized and organized as possible. So here I'm just going through all the screws, making sure that there's the right count. Sometimes you get an odd number of screws. That's completely normal. Usually the supplier will provide you an extra screw of each type in case something goes missing. Now that we have all the screws accounted for, now it's time to get working on the actual frame. Now, the frame itself, this is quite a fun puzzle to be engaged in. Now, you're going to watch me here fiddle around for quite some bit trying to figure out where it goes where. Now, I've made this frame multiple times already, but like always, if I haven't made this in a week or so, I'm going to start fumbling a bit at the very beginning, trying to remember exactly which side goes where. As we see, we have lots of holes and different types of holes. Now right here, I'm showing which side is going to be the front. That right there is the camera holder. So obviously the camera is going to be at the front of the drone. So now we know which side's the front, we can kind of have a better idea and orientate ourselves. That right there is going to be the bottom bit. This is what's going to help hold in the wings for the drone. That's going to hold the prop motors. And you can see here, now that I have an idea of which side's the bottom, I'm going to start working on the outside of the frame. So these parts are going to be used to hold the motor. I'm just going to assemble these guys, put them together, and then from there I'm going to work my way in to have it all connect. And we can see the actual frame starting to take shape. And so now I'm finishing up the other side here. Now the one small interesting part when you have the bottom and the center bit, we can call that, is trying to make it fit inside. I've always noticed the best thing to do is never to fully tighten down all the screws while you're doing the frame assembly, because you're going to make mistakes, but also it's going to give you that little like leverage and leeway for you to actually start get in and manipulate. So here I'm just making sure everything is correct. And then at the end here, as you see, I'm starting to tighten everything down completely. Now that I have the bottom part of the frame assembled, I need to start putting in the screws, which is going to be supporting the ESC and the FC. So these are going to be your longest screws that you have that you're going to be putting in here. And you see, flip it over, it's going to be right there in the center. Now the first thing that's going to go on our stack is going to be the ESC, the electronic speed control. And you can tell it's electronic speed control because of the soldering pads on both sides. There should be 6 on each side, and those are going to be for the motors. Now you see here I'm kind of fumbling around, and I almost made a big mistake at the very beginning. I mistook the front for the back of the drone. It's always good once you have the front and back sides assembled to have it face one way the entire time at the beginning to make sure you don't make any mistakes. So the ESC is going to have several components already attached to it. One's going to be the capacitor. This is for the motors. This is what's going to be used to help prevent a burnout. And then there we also have the power cable, which is going to go to our battery pack. So that's usually the hardest part for me, is honestly soldering all that together. The rest of it though is us working on getting the motors tied to those. And this is going to be a pretty simple task. This is going to be our first bit of soldering that we're going to do here. So here's our first motor, and you can see here there's going to be 3 wires, and those 3 wires are going to go to the 3 soldering pads closest to it on each side. So you see here, it looks pretty simple we're just going to run that across the entire length of the frame bit there. But if you also see that we got a bit too much slack, you see there's a bit way too much. So what we're going to have to do is we're going to have to cut these down to size to make it nice and tight. And that's always the name of the game when you're building drones, is to make everything nice and tight. Slack causes vibrations, and vibrations causes your drone to be less efficient when it's flying. Before I start cutting them, I need to screw in these motors to get them in correctly. Now, a couple things before you're doing this, if you're getting started with drones, you want to get some lock screw. This is what's going to help lock in those screws. These motors rotate at such an astounding rate that even if you over tighten, if you think you've over tightened, you probably haven't tightened enough. And so we see here the number of rotations that we're making 900 rotations possible at max voltage. So it's very common if you don't use any sort of lock screw that these guys are going to fall out once you start flying this guy. And I remember that was the first time when I did my first initial test flight with one of my guys. I thought I had everything tightened, and after just flying for less than 10 seconds, we lost 2 screws. So it's paramount that you get yourself some lock screw and that you start using it beforehand. When applying the substance, make sure you just don't overdo it. You do want enough for the entire thread hole, but you don't want to have it globbed up on there. You definitely don't want it to leak over onto the motors. So now I'm just going to go ahead and start screwing in these holes here, as you see there, and we're just going to rinse and repeat each side. Now that I have all the motors tied down, it's time for me to start working on the wiring here. Now, as we see running across, we need to make sure everything's nice and tight, and to do that, we're going to use zip ties. And we can see here, there's another way for us to tighten down all these wires, and that's going to be through tubing here. Now these tubings are shrink wrap tubes, and so basically you would feed this through the frame there, and then you would shrink wrap it with the heat source. But obviously we can't do that with this guy because we have the bars running across that will prevent us. But here, right here is like my 7-inchers. I use that, a little shrink wrap. It looks a lot better. It can be a little more finicky at times, but honestly, the easiest way and most convenient way is usually just going to be using a zip tie. So with this zip tie, how I usually like to do is do 2 zip ties per wing there. And so right here, I'm going to do one that's closest to the motor, and then I'm going to do a second one closer to the ESC. And while I'm doing this, I'm going to feed it through. I'm going to make sure there's no bumps, that the wires are completely flat here. So you see here, I'm just kind of playing with it, kind of leading it a bit. Don't try to get it too tight with the zip tie at first, because you might make a mistake and you're going to need a little wiggle room. And now you see here, I'm adding tension to kind of hold it in place, and I'm going to add the second zip tie closer to the ESC. And there we go. The wires are nice and secure. You can see there, I got extra slack there, and I'm just going to go ahead and use a plier to make sure it's really nice and tight. You really want to make sure this is tight down. And now I'm just going to grab my wire cutters here. I'm just going to clip off the excess there. So now that I have this one side done, I'm just going to go ahead and rinse and repeat and do the other 3 motors now. Now that I have the wires tightened down to the motors, I'm going to need to work on getting rid of the excess here. So how I usually like to do it is I have a certain way of feeding the wires across. So when you're feeding it through the ESC, the best way to do it is not feed it directly towards it, but to feed it in and around. So you see right here, I have it pinched down, feeding around the screw. And now I'm just going to use my wire cutters here and get a nice straight line across all 3 of those guys, and then do 1 snip. And then I just need to cut off the little extra bit to expose the ends, which I'm going to be soldering. So now that I have all the wires cut to the right length and they're ready to get soldered onto the ESC, I need to go ahead and tin the wires. Now, tinning the wires refers to adding solder to the exposed wire bit there. So this helps get a better bind when you put it to the pad. So I'm just going to put all 3 of these guys attached up, and I'm going to start tinning them. Now that I have all the wires tinned, now I'm just going to solder the actual soldering pads here. And before I did that, I added some flux to the pads. Always add flux. It makes it a lot easier, and it makes for a nicer, cleaner, more even solder onto the item. And now we just got to solder the wires onto the soldering pad there. So of course, get yourself a thing of pliers, and you see here how I'm going to work this through. I'm going to go with the closest one in
and then I'm going to work my way out towards the center. So here's a close-up of the ESC and everything that we've done so far. As you see here, we have the capacitor and the battery pack. And now basically this guy, we can now check to see if the motor and if the batteries are working. And so that's what I'm going to do next, is go on my computer and make sure everything's working. So you can see here I have Betaflight open. This is your go-to software that you're going to use for any sort of testing with your drone or whenever you're assembling a drone, especially a quadcopter, like a basic one like this. So I've opened up right here. This is the motors tab. I have it plugged in. So here in the motors tab, obviously we can see here we have 4 motors and we can actually adjust the voltage. So this is for us to test the motors to make sure we know which motors are working, which ones might have issues, and also for us to change the directions of these motors. Here I'm about to go ahead and test the motors. On the far right, that little button there, I just push that up and we can see all the motors are turning. So yes, the motors are working correctly. Also, always be careful to make sure you have a clear workspace when you're doing these. These guys can go real fast, real quick. Now that we're finished with the ESC, the next thing we're going to be working on is the actual flight controller. Now you can approach this from multiple ways, but how I usually like to do it is start from the front and work my way back. So the first thing we're going to put on is the camera. So right here we have our thermal camera that we got. And I'm just going to connect the wires to the port right there in the back. All cameras, there's different types of cameras, but like I said, we're using analog cameras, and there's going to be 3 wires. You're going to have your video, you're going to have your ground, and you're going to have your power. So the yellow's the video, the red's the power, and the black's the ground. You can see here, obviously we have way more wire than we need to connect these 2 parts. But what I usually like to do, instead of cutting them shorter, because I've had past experience where I try to get it just the right length and I end up overcutting, and then I have a big problem, I just now wrap these around the columns. It's a lot easier. So right now I'm just going to go ahead and start tinning these wires up and get them ready to be put on the pad. When it comes to choosing which ports to solder onto for the camera, I'm going to bring up the diagram here for the SpeedyBee FC. Now if we look in the top left there, we see FPV cam, and we have several ports that we can put onto, but we're only need 3 of these because we're using an analog camera. We're going to need the 5-volt for the power, the ground for the ground, and the cam for the camera. The other ones we do not need to be concerned about when we're using analog cameras. Now after the camera, the next thing that we're going to attach is going to be the receiver antenna. So this is the antenna that is going to be sending information from the radio controller and sending it to our FC system. When deciding which ports to use for the receiver, we have a bit more flexibility, but general rule of thumb, I like to stick with the GPS compass because these drones will not be using any sort of GPS system. So if we look at the bottom left there, we have a voltage, we have a ground, and we have a T6 and R6. While I'm tinning these wires, I'm going to talk about what colored wires to use for each ports. There's a bit of a convention. If you have any experience in electronics, you would know then that our red wires are going to be used for power. Our black wires are going to be used for grounds. And when it comes to the white and yellow, it's a bit more flexible here. Yellow is often used for cameras, so think of it as like the input, and then the white is going to be used for output. Now, when it comes to this receiver antenna, we have a T and an R. So it's both going to need to be able to send information and receive information. So the T is transmitting and the R is going to be for receiving. Hey everyone, Editing Ben here. So when I did this project, I accidentally made a mistake with the VTX that caused the first one to burn out. This led me to forget to film some extra parts here, so I need to go ahead and explain the next step first. I'll bring up a diagram for you guys so you guys can follow along. Once we have the wires soldered onto our FC, then we're going to need to solder the other side of those wires to our receiver here. And there's a little bit of a trick. When choosing to pick where to solder each wire, it might seem pretty practical that the ground should go to the ground wire, the volt should go to the volt wire. But here's the thing, when it comes to the RX and the TX, it's very important that you remember that these need to be crossed. So on the FC, where you soldered to the TX, that needs to be soldered to the RX. And same goes for the RX needs to go to the TX. The next section, I'm actually going to be talking in person while I was working on the project. This is me going over what I did wrong with the VTX. So this is going to help you guys make sure you do not make the same mistake I did. Basically, you have to be very careful to which wires you solder on because there's extra wires on this VTX. And if you solder them onto the wrong point, you could cause a burnout.
this VTX is working. So what I did, the VTX, just showcase to you guys where you put the VTX. VTX goes right here. That's where we're putting it. You see here, power, ground, VTX, data. And as I said, the issue, so basically I need to completely trim these guys off. So this was the issue that ended up happening, was this guy, which was a long cord, ended up touching this guy down here. And that pretty much fried the other one. So I got the other one in the mail. But let's showcase, let's test it, let's see if it's working. Some important things when you're working on the VTX here, there's always caution signs. VTXs are actually quite fragile. Not physically fragile, but like you can mess them up very easily. That is a problem I've noticed when it comes to VTXs. You can damage your VTX very easily. One of the easiest ways to damage your VTX is to not have an antenna attached to it. You always see this warning on any VTX. It says always make sure you have an antenna attached. If you don't have an antenna attached and you turn this guy on and power it up, there's a good chance you might damage it. So you have to be very careful when you're working with VTXs. Always read the manuals. As you see here, manuals always give good indications. And this is where I failed pretty much. I failed to heed this caution right down here. Pretty much RF amplifier is very sensitive to SW, can be turned on, damage to output camera. Yeah, here we go. The 5V output is for camera use only. Please do not connect to the power input and battery. This will cause damage to the VTX. So yeah, that last little point there. So basically that's what ended up happening to my other VTX. I think I've had that mistake happen before and somehow it fixed itself. I just, played around with it for a while. So I might try that again for this guy, but pretty much that was one of the big issues. We got the VTX installed. You see here, we got those connected right there. We need to test it now. So we're just gonna put on the power. You see that we got something there. Got the camera. Hello. Let's go over to my goggles. And we see through my goggles. Boom, you see that? We got something. And just to show you that it's my hand, if I put my hand there, back to goggles. Yep, that's it right there. So, VTX is working, camera's working. That's pretty much all the main things. Next thing is kind of tying this all down, because obviously if we look at this thing can't fly like this. So we need to get everything secure. And this is where we're going to need some 3D parts. So let's look at some issues that we're going to have with this guy. So some of the first issues, actually first let me unplug this guy so we don't get so much background noise. Okay. So yeah, we got a lot of dangly parts here that we need to get tied down. First one we think about is like the camera. We'll start from the front, work our way back. How do we get this camera stationary? Now, when you buy a set for this guy, the frame here, we have, these guys here, which are cool and all. But if you probably notice, we just look at where the holes are and we look at this camera, the camera is bigger than the width. So this guy, we can literally not use these. These guys will not work because the general idea is you put two of these in, you put your little camera in, and then you got these little holes right here, right? You got these little side holes and you can use that to adjust the camera. So you put your screws through there and you can tighten your camera down that way. And it works really well. So, but we can't use that. That's not possible for us. What are we gonna have to do instead? Instead, we're gonna have to make some 3D parts, okay? We're gonna have to make some 3D parts for this guy. All right, so that's part one. Part two is for the VTX. Now VTXs, you can get away with cheating usually on stuff like this. So if we see here, let's see what we got going on here when we put this guy down. We can probably, yet again, use the holy zip ties. Some zip ties. So basically, if we really want to, we can just zip tie this guy down, put this around there, and we might be able to get this guy secured. I have to fiddle around with that one. But then the last one too is we got the antennas. Now, there's a couple of systems we can do with the antennas. If you want to do dirty cheap, you can just put them here and zip tie them. That's an option. For this guy though, you're going to need some 3D part. It's almost guaranteed whenever you're making something for a cherry stem, you are going to need a 3D part. You're going to need a 3D part for this guy, regardless. Okay, you're just always going to need a 3D part for this. Luckily, yesterday I went to the shop to work on some projects to get one of my other drones worked on, and I asked them if they had a spare 3D bit for this, and they did. So I have a 3D bit for this guy and the antennas. It all goes into one. But I still need to work on making something for the camera. So what do? I'm going to go to my computer now, and I'm going to open up Blender. So now I have Blender opened up here, and real quick, just explain why I use Blender. The primary reason why I use Blender is because I've had a lot of background experience in Blender, and when I first started into making 3D printed items, I decided that I was going to use something that I was familiar with. There's a lot of other softwares which are dedicated to making 3D models, and I should probably start learning a bit more about them, but for right now I'm sticking with Blender because I'm quite comfortable with it. So this model here, also, I got this model a while back from someone else when I first needed to make a drone that had a rotational camera. Now this is version 4 of that model. I've made it far more sturdy, and I've added a couple features to improve a couple options. So now what I'm going to do is I'm going to export this as an STL file, and I'm going to bring it into Prusa Slicer. So Prusa Slicer is the actual software used by the 3D printer. And so there's 2 stages pretty much whenever you're making 3D type stuff. You're going to have the first part, which is the 3D modeling, and then you're going to have the 3D printer. So in here real quick, what I'm doing is I'm doing a quick algorithm cleanup, which takes care of any small issues like open vertices and whatnot. And so now I need to adjust the model that I have imported and make it ready for printing. So I'm not going to get too much into these sorts of things. You guys just watch real quick how the process works here. But I just got to make sure that the print looks good. Right there, we're seeing basically scaffolding to help hold the print up. And basically, you just kind of work through this and make sure everything looks good before you begin printing. So once I'm happy with the file, I can export it and put it on a USB thumb drive. And I just take it to my printer, plug it in, and load up the file and hit print, and then it'll start working on our camera mount here, as we can see. Now I finished 3D printing all the parts we're going to need for this drone. I'm just going to showcase them to you guys. So the first one is for the camera. This is 2 parts. There's 2 3D print parts here. The first part is attached to the drone and held in by those beams there, as you can see. The second part is actually going to hold the camera. And why this is a 2-part system is because this is based off the original servo design. So originally this was made to have a servo at the bottom, which allowed us to control the camera and move it up and down. But this camera doesn't need to be moving. So we're just going to change our design a little bit and have it fixed in. And see here, it goes in the front. That's where that support beam is. That's what's going to hold it in place. The next 3D part that I'm going to show you now is going to be for the antennas. This is going to hold all the antennas. Now I have 2 printouts here. One was the green, one's the black one. These are different plastics, and basically what ended up happening, I used the green one. I thought it would be nice to have a nice sturdy strong one, but the problem is basically this is going on the back of the drone and it's going right next to where our battery is. And often when you have to do test flights and all these other things, you're going to unplug the battery and plug it back in. And what ended up happening was whenever I pulled on the battery plug, I would end up hitting this plastic part here, and it would hit those top antenna bits and that would snap. So obviously I found this to be a big issue. So instead of having like a rigid, strong plastic, I needed a plastic that would be able to give way and that would be more flexible. So I switched over to PETG instead of PLA. Now that we have our 3D parts, we can finish assembling this drone and get everything put together. So the first thing we're going to work on is going to be our receivers. The first thing we're going to do to the receiver though is we're going to shrink wrap it. We're going to provide this protective wrapping to help protect it to make sure it doesn't get damaged while it's in flight. To do this, basically what we're going to have to do is we're going to have to take off the 2 antennas, slide it on, reattach the 2 antennas, and then just heat wrap it. The next part we're going to tighten down is going to be the VTX. So the VTX, like I said earlier, we're just going to use zip ties to hold it down. It's just finding the right position for the zip ties. And also to make sure when we put the zip ties on that we don't obscure any of the buttons that we're going to need access to. The next item is going to be the camera mount. There are 2 front holes at the bottom of the frame that we can use for the columns of our joint here. So I'm just going to put these screws in. They're going to connect to that column, and that's going to tie it down. And there's going to be 2 screw holes at the top as well. So this is what's going to have a real tight fit, and it's not going to be wobbling, because that's always one of the biggest issues if the camera, when you're flying, you want a very steady camera. Next is going to be attaching the camera to our camera mount. And so what I'm doing right here is I'm putting all that extra wire, all that extra slack around the 1 column in the back, And I'm trying to feel to see, so we have enough give, but not too much give. So see, I'm just working out where it's a good fit. And now I'm just positioning the camera so the screw holes on the camera and the screw holes on the camera holder are aligned. I just want to show you guys before I screw it in to show that it is really nice and tight. Let's see, we try to move it here. It's a nice tight fit. So now I'm just finishing up the camera and now screwing in the side bits there to hold it in place. So to finish up the bottom, all we need to do now is put in the last columns, and then we can start working on the top side, and this will completely secure our drone. The next step is us securing the FC and the ESC to make sure that they don't move while they're in flight. So to do that, all we need are some nuts, and we're just going to go ahead and screw those on and tighten them down. Now, one note though to take is when you're tying it down, you don't want it to be too tight where it's pushing down. You do want it to be able to give a little leeway. If you push on it, it goes up a bit. This prevents any of the cords or any of the wires touching each other or any of the plates. Now we're just going to install the top here. So I'm making sure everything's in place. Make sure all the columns are nice and tight and just getting it lined up. And now we're going to work on the last bit, which is going to be the antennas. So you see here I have my 3D printed antenna holder. I'm just going to put that in the back, screw that down. And now that once this is in place, I'm going to go ahead and install the cherry stem through there. And you see here, I'm just going to use some pliers to work around there and make sure we have a nice tight fit. Next is going to be securing the receiver chip. So you see here, I'm kind of working it in the back, and what I'm planning on doing is using a zip tie, but what also I want to do is take all that extra slack, all that extra wire, and kind of bundle it up on top of it and have it pressed against the top of the frame to hold it all in place. So we're almost done with our drone here. And if you notice, the antenna is different. So this is past me not realizing that this plastic is going to be too rigid and it's going to snap when I take it out in the field and I try to unplug a battery from it. And the reason why I didn't use the other guy was because the holes were actually too small for the zip tie. So I had to go ahead and put this guy in. So I'm just going to tighten everything down and check to make sure everything is good to go and cut off all the extra zip tie bits. Now I lied there. So the actual very last thing you're going to do when you're building a drone, and you see what I'm fiddling with right here, is a little adhesive bit that you're going to slap on top of it. And this is what's going to help grip the battery in place. So this concludes part 2 of our drone creation series. In part 3, I'm going to go over the software side, talk to you guys about what it takes to actually get this guy up in the air, moving, and have it connect with your controller. I apologize for it taking me so long to get these videos out. It's a lot of learning for me on the video editing side, and there's other projects I've been constantly working on, and I always kept putting this back. But now that I'm heading back to Florida, I'll have some free time, and I plan on having part 3 up and ready a lot sooner than it took me to get part 2 up and ready. If you guys have any questions, please let me know. Also, let me know if you like these videos or not. This took me a lot longer than I thought it was going to take me. I had no idea it was going to take me several full days to just edit 30 minutes worth of video. But that's what it takes to make these sort of things. So I hope you guys enjoyed the video. Thank you for sticking around if you've already to the end here. And I hope you guys learned something about the drone systems and what it takes to actually make drones work.